Today we're going to be working on single replacement reactions, also called single displacement. And remember, I like to think about this as a dance. We have this single guy came to the dance with this couple, hydrogen and chlorine. So hydrogen's going to be dancing with chlorine, but magnesium wants to see if they can switch places. So today we're going to see, will that reaction happen? Is magnesium strong enough to boot out hydrogen or whatever else we're looking at? And in order to do that, we need to check our activity series, which is in your reference sheet. So let me show you that. You have a much prettier activity series now. I souped it up, but here is your activity series. And basically, I like to think of it like this. First of all, these are our metals and these are our nonmetals. Metals can only kick out metals. Cations can only replace cations. So the reason that magnesium is booting out hydrogen and not chlorine is because magnesium, when it forms an ion, forms a positive, hydrogen forms a positive, and chlorine forms a negative. And remember, you can find all those charges written right above your groups in your periodic table. So all these nonmetals over here form negative ions and all our metals form positives. So magnesium will switch out with hydrogen because a positive needs to be with a negative, okay? Because opposites attract and the same charges would repel. So how do we know that magnesium is strong enough to boot out hydrogen? So that's where we look at our activity series. And right here is magnesium, because it's a metal, and hydrogen is in the metal category. But here's our hydrogen. And what I like to say is there's going to be a fight for that girl, and usually in a fight, the guy on top wins, right? So magnesium is above hydrogen. It's the guy on top. It can kick out hydrogen. Okay, so that's why this reaction does occur. So let's look at our worksheet. Here is our worksheet, and what happens is these metals on the top of our activity series are more reactive. They're more active, so they can kick out the ones below them. Same with the nonmetals. So let's our first example here, and I'm going to zoom in. Burp, burp. And what we have here is we have a metal, and on my first group is metals, okay? So it's going to kick out the first guy. These are going to switch places. Now, can this happen? How would I know? Well, here is my potassium, and we're looking at silver. So my silver is right here. Now, potassium is above silver, so it can switch places. It can win that fight. So we're going to just write, yes, the reaction will happen. And then I want you to write what will replace what. So K is going to replace or switch places with silver. Okay, why? Because the guy on top wins. Now, here I have the reaction reverse. I have silver as the lone guy, the lone metal, and can it replace potassium? So I have this backwards, and here's my silver again, and here's my potassium. Silver's the guy on the bottom. He's not going to win that fight. So silver cannot replace potassium. So we're going to put NR for no reaction. Here, you don't have to write this. I just put that silver is below potassium, so you know why there is a no reaction, and then nothing will replace anything there. So you can just put a line there. Okay? Now, our second part, I have separated them, and now we have our nonmetals. So our nonmetals, or chlorine, would form a negative ion if it turns into an ion, and magnesium's your metal, is positive, and this is negative. So chlorine now has to switch with the negatives, right? Because when they go together, I need a positive and a negative together. So make sure you understand that. And now we need to decide, will chlorine replace iodine, okay? Because chlorine's going to replace the negative anion. So chlorine's going to switch with iodine. So here's chlorine, and here's iodine. Chlorine is on top, so yes, a reaction will occur, and chlorine will replace iodine. I want to know that you know which two are going to switch. Okay, and here I've reversed it so you can just see the opposite reaction. Here I have iodine's the lone guy, and that's the negative, so it's going to have to replace chlorine, okay, because these are nonmetals. You could think about two nonmetals are going to switch places. And we have iodine here is below chlorine, okay, and since it's below, iodine will not win that fight, and there is no reaction happening, and then you can just put that there. I put I's below chlorine just as a trigger so you know why no reaction happens. Okay, so this is your introduction to single replacement reactions. Tomorrow we will be writing full reactions there.